Now we're next going to get some practice finding the union of two sets. And we're going to look at exactly the same sets that we considered a minute ago when we found the intersection of two sets. Now I think this will be really helpful for you to see the differences between these two set operations. So first example, the set consisting of 1, 2, 3, and 4, and the set consisting of 3, 4, 5, and 6. Now one way to think about the union, if you will, imagine putting all the elements from the first set 1, 2, 3, 4 into one bucket and all the elements from the second set into another bucket. If you were to take and dump those two buckets into a third bucket, what elements would you have? And all those elements then would be those in the union of those two sets. Now, the only thing to keep in mind is that if an element appears twice in the third bucket, meaning it appears in both sets, then you only list it once in the union. So in our case then, the union will consist of the elements 1, 2, 3, 4, 5, and then 6. Now the next example, as we did with the examples involving intersection, I've graphed each of those sets using the appropriate color, green and blue. Now for the union, what you want to picture is what graph would you need to put on the number line that would encompass all the points on both of those graphs, the green and the blue graph. And I trust you can see that we're going to have to go all the way out to the left to -3 and all the way up to +8 to find a graph that would include all the points on both. So let's then next show that on the number line itself. So would you agree, I hope, that the graph in red below there on the number line between -3 and 8 would indeed include all the points in the green graph and the blue graph. So therefore we can write in interval notation that the union of those two sets then would be -3 to 8, but you'll notice it does not include either of the endpoints. Now in our final example, we have the sets -infinity to 7, including 7, and then also from 7 to infinity, including 7. And each of those sets is graphed below there in green and blue. And you will notice that with the green graph, it goes infinitely far in the negative direction, and in the blue graph, it goes infinitely far in the positive direction. Now, can you visualize what we would have to graph on the number line itself that would include all of the points on both of those graphs? And I trust after a little reflection you would agree that would have to include all the numbers on the number line, therefore all real numbers. So let's show that next. So the union then is graphed in red, and we would write then in interval notation that the union would be -infinity then to infinity, which would be all real numbers. And then sometimes you will see the set of real numbers represented by writing a big fancy R. Now our next example is asking us to find the union of the sets -infinity to 7 and 17 to infinity. And each of those sets is graphed below there in green and blue. Now, can you visualize what you would have to graph on the number line itself that would include all the points in both of those graphs? Now, since they don't overlap, really the best that we can do to represent the union would be simply to replicate each of those graphs on the number line itself. So we'll do that next. And if we were now to represent the union of those two sets, then I think you can probably see it would simply be the same as the original problem. So what we can write then would be -infinity to 7, union with then 17 to infinity. Now in our final example, we have the union of the sets -3 to infinity and 3 to infinity, and you'll see them graphed below. Now take a minute to determine, if you can, what graph would you have to put on the number line itself that would include all the points on both graphs. And after a little reflection, I think you can see, hopefully, that it would be everything from -3 to infinity, which basically is the same as the first set or the green graph. So we'll show that on the number line next. And so the union then we can express in interval notation by simply writing then -3 to infinity.